Hello and welcome to the CellNetAnalyzer tutorial. In this video we will calculate the constraint minimal cut sets such that an ethanol yield of at least 1.5 millimole per millimole glucose is guaranteed, while a minimal biomass yield of 0.01 gram dry weight per millimole glucose remains feasible. We restrict the size of the minimal cut sets to 6. We start with our previously computed set of elementary modes, and again select all. We select Yields and Rate Ratios in the Statistics pull-down menu, and click Compute. Our set of desired elementary modes is specified by two criteria. First, the elementary modes should have a biomass yield that is bigger than 0.01. 38,146 modes that satisfy this constraint are selected. From this current selection we now select a subset of elementary modes that additionally fulfill our second criteria, an ethanol yield that is bigger than 1.5. Now 5,882 modes are selected that fulfill both our criteria. Let's check the ethanol yield distribution for the current selection. We can see that the yield is always at least 1.5. Let's save the current selection of elementary modes into the clipboard. We will need them later. Therefore, we click Clipboard and Set Operations, and Selection to Clipboard 1. To specify the target modes we first select, again, the complete set of elementary modes. We click Select All. Then we select the elementary modes with an ethanol yield of at most 1.5. (50,262) target modes are selected. For the computation of our constrained minimal cut sets, we select Minimal Cut Sets in the Statistics pull-down menu. We click Compute, and tick the checkbox for Save at least one mode from Clipboard 1. Further, we restrict the maximum cut set size to 6. Then we click the Start Computation button. We can follow the progress of the computation in the command window. (1,442) constrained minimal cut sets satisfy our chosen constraints. The first cut set comprises 5 reaction knockouts, which are displayed in the network map. We compute the histogram of the cut set sizes by selecting Cut Set Size Histogram in the Statistics pull-down menu, and click Compute. In the histogram we can see that the minimum cut set size is 5, and there is no cut set bigger than 6. This is because we previously set 6 as an upper bound for the cut set size. Let's now verify the correctness of these calculated constrained minimal cut sets. Therefore, we implement one of the cut sets and check that the minimum ethanol yield is indeed at least 1.5. We use the first cut set, which is displayed in the network map. The 5 reaction knockouts are presented by red 0 values. The reaction which were disabled in the anaerobic growth scenario are indicated by green text boxes. We restore the anaerobic growth scenario by setting the reaction rates of these green reaction back to 0. Further, we set the uptake rate of glucose to 1, and we check that the objective function coefficient of the ethanol production reaction is set to 1, such that it will be minimized. To ensure that no other reaction is participating in the optimization objective, we can check the objective function by clicking Analysis, Flux Balance Analysis, Show Objective Function. The objective is displayed in a dialog window. Then, we start the flux optimization. We click Analysis, Flux Balance Analysis, Flux Optimization, and choose GLPK as linear programming solver. The computed optimal flux distribution under the cut set is shown in the network map. The minimal ethanol production is, as expected, bigger than 1.56. Thus, we have verified that the cut set satisfies our constraints.